Hi grade 12s. I know I haven't made many videos for you, so I'm going to, explain what it is that I want from you guys in today's notes. Before I go on, I just want to make sure that you guys, there was quite a few errors with how you're to do the hydronium ion. So it's very interesting because if this is water, and you have an H plus proton, it doesn't have any electrons. And so the water will actually donate one of its electrons and bond with it. We'll learn more about that in the structures unit. That's called a coordinate covalent compound. And so what happens is you get something that looks like this, and the whole thing is positive. So we write it H3O+. That's the hydronium ion. Remember, hydrogens do not exist by themselves. They're too unstable, so they have to find a water to bond and turn into hydronium. The other thing that I want to say, every time you see these questions, pretend they don't exist. Okay, this is I use a different textbook when I taught at a different school. And so all the questions that I'm ever going to ask you, they're going to be on your Google Classroom note, and they're going to be on my website note. So you can just disregard all of these questions. Okay. All right. So now we're looking at the acid ionization constant. I want you to be able to understand. It looks very much like an equilibrium. Well, it is an equilibrium constant. It's just for the dissociation of an acid or a base. It's how much is it going to dissociate. And remember that the strength of an acid is based on how many protons or which turn into hydronium, but how many protons are able to be produced. Okay, so obviously this, we aren't going to do anything. Down here, this is what I want you guys to look at, because it's interesting and it's important for you guys to understand. We can do a couple of examples together. Whenever you look at one of these substances, you have to be able to recognize if it is an acid or if it's a base. Remember, an acid is a proton donor, and then a base is a proton acceptor, according to Bronston-Lowry. And Arrhenius says that an acid can give a hydrogen and bases give hydroxides. So when I'm looking at NH4+, guess what? This is actually, according to Arrhenius, it can give a proton. So this is considered an acid, and obviously this is considered an acid here. So this is a proton donor. But what about NH3? NH3 is a base, but only according to Bronston-Lowry. Why? Because it's a proton acceptor. There are no hydroxides for NH3 to give off, so Arrhenius wouldn't recognize it. Okay, there are some tricky ones, like something that is -1. Okay, if it's an anion, is it going to attract or repel a hydrogen? Well, minus and positive attract. So is it going to donate or is it going to accept a proton? Minus is going to accept a positive charge, so it's going to act as a base. Is Arrhenius going to accept it? No. So I actually put crosses there, okay? So I could say can accept a proton, and it turns into, this is acetic acid, OH, okay? Sorry, O3H. So I usually write it like this. Okay, still 2. There we go. All right, so these are tricky. Don't worry about it, just try them, okay? So there's only, what, 6 or 7 of them for you to try on your own that I gave you the other examples for. Look at them, try to figure them out on your own, okay?